Alright, so this is a nice, challenging problem. This problem has 1,000,000 steps, and there's lots of small places to make mistakes, so I apologize in advance if I make a mistake, and we will catch it as we go. So in general, when we find the roots of a polynomial, we can find the factors of p and q, in this case -50 and 1. We can figure out all these factors, we can write p over q, write all the possibilities out, and we can do synthetic division and see if the roots work. In this case, this is a super challenging polynomial because it has 2 complex and 2 irrational roots. Now you'd have no way of knowing that right away, but I know that because I know I've done it before. But a great way to start these is to put this into your calculator. So I'll pull up my calculator here and I'll put in our polynomial. So there's our polynomial. I'll double check. When you have this on your test, go nice and slow, double check all your answers. It's super easy to make mistakes. This is a good problem to save for the end. All right, there it is. I'll zoom standard and plot it. All right, one thing I noticed right away is this line is super steep, so it's going to be challenging. It's going to be tough to get my cursor in the exact right spot, so I'm going to change my window. My x is fine, but I want my y to be bigger, so I'm going to go from -100 to +100. So let's have a look. And that looks a lot more reasonable. So now I'm going to find my zeros. I'm going to go to second calc, 0. I'm going to go for this one first. I will go to the left of my 0. And if you lose your cursor, just look here and it'll tell you the coordinates of your cursor so you can kind of figure out where it is. Okay, now this next part's important. So see how it gives me the 0 here? So what it's actually done is it's stored that 0 value in x, so -4.19. So if I leave my plot and I type x now, there it is. Now what I'm going to do is I'm going to store this as alpha a. So I'm storing this as the variable a. If I press a, I get it back. Now same game again with our other root, second calc 0. So I'm going to compute the 0. Now see it's getting less negative. There it is. Okay, left, right, and enter. Okay, so now same story again. X is the root, and I'm going to store it as b. Okay, I want to make a quick point here. It's an important point. So it says exact roots. So recall that irrational numbers are things like the square root of 5, something like that. So the square root of 5, for example, we can write that as a decimal, but we can't write it exactly as a decimal. So this is an approximation of the square root of 5. But when it says to find the exact roots, that means that our final answer can't be these long decimals. These are going to be an important part of finding our answer, but these can't be our final answer because, I got some marker on my calculator, because it says they have to be the exact roots. Okay, hopefully that marker comes off. That sucks. All right, so the first thing we're going to do is we're going to use the a and b we just figured out, and we're going to use synthetic division to find a depressed polynomial in terms of a and b. So let me show you what I mean. I'm going to start my synthetic division here very carefully, and my first root is going to be a. I know that it's this decimal I have in my calculator, but I'm not going to be worried about that right away. And now I'm going to do regular synthetic division. So 1 minus 3 minus 13, 60, minus 50. All right, 1 comes down, and now I have a variable here. So 1 times a is just a. Here I'll get a minus 3. A times a minus 3 is a squared minus 3a. Add these together, I get a squared minus 3a minus 13. Okay, this times this. I'm going to switch colors here, it's going to get a little busy. This times this is a cubed. I should have left more space. Try to leave more space on your test. 3a squared minus 13a. All right, I'm going to draw a little dotted line here. I'm going to add 60 to that, so a cubed minus 3a squared minus 13a plus 60. And then one more step here. And I'm going to kind of skip a step here. I know I multiply everything by a and I add -50. It's going to turn into a to the 4th minus 3a cubed minus 13a squared plus 60 times a minus 50. Kind of squeezing it in there. Okay, here's an important part. We know that if a is a root of our polynomial, and we do synthetic division, our remainder should be 0. That is our remainder theorem. And it's a special version of our remainder theorem called the factor theorem. So now I'm going to type in exactly this equation into my calculator, and if I've done my job right, and I have the right value of a, I should get 0. So let's check it. This is an important test I want you to do on your test. So a to the 4th all right, and if we've done our job right, we should get 0. So cross your fingers. 0. Okay, so it doesn't say exactly 0, but I know that this is a very small number, times 10 to the minus 11th, so I'll take it. That's close enough to 0. That's going to be fine. So I'm going to put a check mark. We got this right. And now we have one more important step, and that's to synthetically divide again, and this time with our second root. All right, so and now we need to find the coefficients of our depressed polynomial, which is this mess. All right, so 1, a minus 3 is our next coefficient. Our next coefficient is a squared minus 3a minus 13. Okay, and technically we should write this one, but we can actually skip a step and save some time, because the result of this calculation is the remainder, and if b is a root, our remainder should be 0. So we're actually going to try to save some time here and leave this out for now. So I'm going to bring my 1 down. 1 times b is b. Add these together, I get a plus b plus 3. Oh, excuse me, that's minus 3. A plus b minus 3. Multiply these, and I get ab plus b squared minus 3b. And then add these, I get a squared plus b squared plus ab minus 3a minus 3b minus 13. Okay, so now hopefully, if we've done our job right, these should come out to whole numbers. They should come out to whole numbers, so let's try it. So we'll do alpha a plus alpha b minus 3, and we get minus 6. Which is great. It's a nice whole number. And now this is the tough one. Cross your fingers for this one. So alpha a squared plus alpha b squared plus alpha a alpha b minus 3 alpha a minus 3 alpha b minus 13. Cross your fingers for a whole number. Boom, 10. All right, things are looking up. 10. So I can do math past 10 o'clock at night. That's a good sign. I'm not super old yet. So 1 minus 6 and 10. So that means that our depressed polynomial is x squared minus 6x plus 10. So our next job is to find the roots of this guy. So we're on the right track here. I'm going to take this away because I'm out of space here. So I'm going to put this off to the side. There's a nice bleed through page. Beautiful. I love wasting paper like that. So I'm going to grab our polynomial from our last page. So we're going to remember that it's x squared minus 6x plus 10. So we have x squared minus 6x plus 10. This is just a good old Pythagorean theorem. Negative b plus or minus, negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm going to plug in here. So negative 6 is just positive 6, plus or minus square root of 6 squared is 36, or negative 6 squared is still 36, minus 4, a is 1, I'm going to leave it out, times c, which is 10, over 2, and that equals 6 plus or minus root negative 4, 36 minus 40, negative 4, over 2. I'm going to go ahead and simplify. 3 plus or minus, this is actually 2i, because the square root of 4 is 2, square root of negative 1 is I, and 2i over 2, so this is 3 plus or minus I. Okay, there we go. So we have 2 roots. We also have a and b in our calculator, but remember that those don't really count because we have to have exact answers. We can't have these approximate answers. So what are we going to do? We're going to have to use these roots to synthetically divide one more time, and that will give us the actual, it's kind of sucks because it's going to give us the same, the same numbers as this, but it's going to give us in a rationalized form. So for example, this could be like, I don't know, like 1 plus root 5 or something like that. That might be this number, I don't know. But by doing synthetic division again and finding another depressed polynomial and solving that, we can figure out the rationalized form of this decimal. I know it sounds like a lot of work, and it is. This method is terrible. I tried to find a better method, honestly, but I read some graduate level paper and the formulas were insane. So I think really when you're doing these by hand with the calculator, this might be the best way to go when you have to find irrational and complex roots. So that being said, let's give it a shot here. So I'm going to take our original polynomial, which is this long mess. I'll put our synthetic division sign up here. Make sure that's on the screen. Okay. So we have 1 minus 3. I'm going to leave some space this time. Minus 13, 60, and minus 50. Okay. And now I'm going to put in our first root. So I'll put in 3 plus I. Okay. There we go. So now, here we go, same game again. Be careful, take your time, don't rush on this. If you feel like this is going slowly on your test, just skip it, come back to it later. So bring the 1 down, 3 plus I, okay, the 3's canceled, that's kind of nice, we're left with I. Now we have 3I, and then that's minus 1, so 3I minus 14. All right, and now we're gonna have to FOIL, which sucks, here we go. So we have 3 plus I times 3I minus 14. So that's 9I minus, it's getting late, 14 times 3 is 42. Okay, I times 3I is minus 3, and that's minus 14I. Okay. I recommend writing your foiling out like this. You can do it in your head, but it's just so easy to make mistakes. Okay, there we go. So we have minus 5I minus 45. Add these together, we get minus 5I plus 15. I got my signs there, right? I think, let's see. Yes, 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 okay. And now if we did our job right, remember this is a root, so our remainder should be 0, so cross your fingers. We have to FOIL again, so we're going to FOIL 3 plus I times minus 5I plus 15. 3 times minus 5 is minus 15I, so that's done, plus 45, oops, excuse me, 45 minus 5I times I is actually plus 5, and then we have a plus 15. That's a good sign. Our imaginary parts are going to cancel out. This is just 50. There we go. Math works. So 50, and we get 0. So now we're going to write our depressed polynomial down here and synthetically divide our other root, which is 3 minus I. Our depressed polynomial is 1, I, 3I minus 14, and minus 5I plus 15. There we go. Same story again. Let's get to work. 3 minus I. Oops, excuse me. That's just a 1. Now 3 minus I. 3. Okay. 9 minus 3I. Ooh, those cancel. That's nice. All right. I think we get minus 5 here because those go away, and minus 14 plus 9. Hopefully this will all work out. Minus 5 times I is plus 5I. Excellent. And this is minus 15. Boom. There you go. Math. Okay, good. All right. So our depressed polynomial is then x squared minus 3x minus 5. We want to set this equal to 0, and now we're going to solve our roots, which again, remember, that's just our a's and b's, but we're going to find a and b in a rationalized form. So again, let me throw out this paper I've ruined, and we're almost there. So Now it is quadratic formula time for one last go. So negative b, which is 3, plus or minus the square root of b squared, which is 9, minus 4ac, which is 4, a is 1, c is negative 5, over 2a, which is just 2, 3, plus or minus the square root of, here we're going to get, I think it's 29. I hope that's the right answer. 29 over 2. Okay, I really hope that's the right answer. So actually here, I was going to look at the solutions, but we don't have to do that. We can actually compare it to our a's and b's. There's the a we got earlier. So I'm going to type in 3 plus, I'm just going to compare this number and see if it's the same. 3 plus root 29 divided by 2. Let's cross our fingers. Oops, not cosine. There we go. Okay, ooh, that's the positive version of that. I must have made a little mistake. Shoot, okay. That's all right, this happens all the time. Like I said, there's a million steps in here. I have the exact opposite of what I want. See, I got the same number, just negative in both cases. So we're really close here. If you're on your test, you could almost just put a minus sign in front of each answer since you know you're so close. Let me look at our solution here really fast to make sure. Yeah, so that 3 should be minus. Oh, there it is. Yep, there's my mistake. So this, in my synthetic division, this is a plus 3. I don't know why I thought it was minus. So that's minus. There you go. And that's going to be the right answer. Okay, so there's a million steps. It's a hard problem. Practice. Save this for the end of your test. Be careful and really focus on accuracy, not on speed. If you focus on speed, you're just going to make little mistakes. So really focus on accuracy. Don't let the clock scare you. If you're worried about the clock, do other problems. Come back to this one. Good luck.